All right, so the next concept that we're going to do has to do with rationalizing denominators. Right? And so one of the things to be aware of is a term called conjugates. And so a conjugate, we're going to see it with radicals, and we're also going to see it with complex numbers, or i's, and the imaginary number I a little bit later. Right? And what a conjugate is a conjugate takes the same term, right? And the conjugate is the exact same terms, but with the opposite sign between them. Okay? So it's not taking the opposite of the terms, and what it's doing is it's just changing the sign between the two terms. And the whole point of conjugates is it's based on the idea that when you take a plus b times a minus b, you get a squared minus b squared, and where the outer and inner products of a FOIL system cancel each other out. And so what that winds up doing is it allows you to get rid of square roots and allows you to get rid of i's and turn them into I squareds. And so conjugates are just based on the sum and difference, or taking the product of the sum and difference of terms. And so if your original term is the quantity a plus b root c, the conjugate of it is going to be the same two terms, a and b root c, but in order to get this form where it's the sum and difference of terms, we need to change the sign to a minus. And so what would be the conjugate of this middle term here? Root a plus root b. Perfect. And the last one would be? Perfect. And so that's what a conjugate is. Again, it's just allowing you to get the sum and difference of terms so that the outer and inner products cancel out. Okay? And so we'll come back and use conjugates in a second, or probably